Hey, I guess you're pretty happy with yourself. You've gotten to the last presentation in simplifying our algebraic fractions here in Algebra land. So let's have a look around the screen as usual. And I've got a question, always got a question for you. But a young mathematician that you are, here's the question. What does cancelling a fraction really mean? And cancelling is not really a mathematical term. So let's look at its mathematical meaning, cancelling a fraction. I think what it means is finding a common factor which divides into top and bottom. And if you can do the same to top and bottom of the fraction, you're not changing its meaning or its value. Remember, in an earlier presentation, we said we can multiply top and bottom, here's one here, of a fraction by the same number, and that's equivalent to 1, isn't it? 2 over 2 is 1. Well, now what we could do is to multiply top and bottom by what will go into 12 will also go into 18, a 6. So we could find a 6 of the top and a 6 of the bottom. In other words, we can do, and that's the same as multiplying by 1. But we could simplify that and say multiplying by 1 6 is dividing the top by 6 and the bottom by 6. So that comes to 2, 6 into 12 goes 2, 6 into 18 goes 3. So that's what we do quite routinely with ordinary fractions. Hey, what about this? And there's a couple of others down here, mate. Let's come down and have a look. All of these. Do you reckon we can do something with those as well? And what's the answer? The answer, of course, is yes. And what's the reason why we can work with algebraic fractions and divide top and bottom by a common factor? And that's what cancelling really means, doesn't it? Dividing top and bottom by a common factor, something will go into both ones. Why can we do it in algebra land? Because the pronumeral just represents a number. It stands for a number. The letter stands for a number. Because pronumeral represents just an ordinary number and represents a number. Okay, so don't pick on x. X is as good a number as 9 or anything else there. Okay, do you remember that? Let's do this one here and say what goes into 9 but also go into 36. Divide 9 by 9 goes once. 9 into 36 goes 4. So this comes to a quarter. What about 25 and 75? Well, the whole of 25 divided by 25 is 1, and 75 divided by 25 is 3. Or you might have to do that 5s at a time. Divide top and bottom by 5. Let's do it that way, because you might not have spotted that big factor. 5s into 25 goes 5. 5s into 75 goes 13. Hang on, it goes 20. Hang on, and what have we got here? Gets 15, sorry. And now dividing top by 5 goes once, bottom by 5 goes 3. So it comes to the same thing, doing it in stages. Okay, so you might have a go at 16 over 12 and see if you can make that come to 4 over 3 or 1 1/3. Our emphasis in this unit here, on this presentation, is what does cancelling mean? Dividing top and bottom of a fraction by a common factor, and we're going to try and do it with algebraic fractions. So come on down and let's have a look at what we can do there. And here it is. Here's a summary of what we've just said. You could write this in your notes to remind you, if the numerator and denominator, they were the big terms that we introduced in the last presentation. The bottom line of the fraction and the top line of the fraction are both written in factored form and common factors are found. We can simplify by cancelling the common factors. So in other words, often we do this in our head. Oh, what did we say? 16 over 12. We think of factors of 16, but also factors of 12. So 16, 4 goes into it 4 times, and 4 goes into 12 3 times. We generally don't have to worry about doing this and looking for the common factor. We can just think about it in our head and then divide top and bottom, which is what's called cancelling, by that common factor. Okay, do you get it? And because we want to do it with algebraic fractions now, so screen clippings here from Hayes and Harris Publications, their Australian curriculum book for Year 9, so you should buy that and have a look. So let's look at algebraic fractions. We're looking for something they both have. Well, if we think about what AD means, we leave out the times. It means A times D, and 2A means 2 times A. Gee, there is a common factor. We can divide A into itself there, it goes once. A into itself here goes once. So that goes out. So we're left with just D over 2. 1 times D left in the top line, and 2 times 1 left in the bottom line. Let's do a harder one, this one here, A squared B. Let's write A squared out as a product of factors. It's A by B. And AC is A by C. What's common? Well, let's cancel A into itself, divide A into itself, it goes once. Divide A into itself in the bottom line, goes once. So what's left? 1 times A times B, or just AB. Remember, we leave out the multiplication sign in algebra. And then 1 by C is just one lot of C. So do you get the idea here that it's important to go up close and personal with these numerals and realise that they, in a problem, if they're used, they always mean the same thing wherever they're used in that problem. And it's just a common factor there. Whatever the value is, it's common right through that problem. Okay, let's look at this one. 3, there's no times sign, but it means times A, times another A, see that? Squared, we've been doing quite a bit of that. And then times B, bottom line 6, let's split that up, 2 by 3, so we can see any number factors for those two numbers, the 3 in the top line and the 6 in the bottom line, and then times by A, and then times by B squared, B times B. Now laying it all out like this, we can see, well, the 3 will go into itself once, and it will go into this 3 here once. So it cancels the 6 down to a 2, if you like. You might not like to put all this out, but you can. It shows the way. And then you've got A by A. Well, let's cancel the A, goes into itself once, and into this A once. And then the B, cancel into itself once, and B squared is B by B, so cancel one of those out. So crossed out the common factors. What have we got left in the top line? 1 times A times 1 times 1. The only thing that's left in the top line is A in the numerator there. In the bottom line, we're left with a number factor 2, and that A's gone, the 3's gone, that B's gone, we're left with one B factor there. So the answer is A over 2B. Can you see it's exactly the same as if we had actual number values there with our pronumeral, because the pronumeral is representing just another number. Good stuff, isn't it? Okay, so here's 1F1 from the Hayes book now. I'm doing it in a slightly different order from what they did, because I thought it became more logical if you do addition and subtraction, multiplication and division, and now cancelling in that order. So we want to try and write the top and bottom lines as factors, all written out, broken down, times together. Factors are two terms which multiply together to give the expression or to give the number. So I want to write all of these out with lots of times in them, and then see what they have in common, and to divide top and bottom by that common factor. Okay, pause the presentation, have a go at a couple, but don't do them all without checking the answer. So toggle forward on the video now and check your work. So I'll pause it and then show you the answers, and you can go back and forward and complete the exercises. So here are the answers. And there we have it. All right, I hope you can study that carefully and see how to get those answers, because that's the end of that series of presentations on algebraic fractions. I hope you've had fun, and just practice, you'll get good. Cheers for now.